Hi class, this is Dr. Karsten, and I'm going to be showing in a little bit of a different way how to convert fractions greater than 1 into mixed numbers, and also how to convert mixed numbers into fractions greater than 1. So here you can see that I have a whole cookie, and here you can see that I have a bunch of cookie pieces. And what I want to do is I want to figure out how many whole cookies there are in all these cookie pieces. So I'm going to take away the whole cookie, because that was just to show you. And what I'm hoping that you can see is that each one of these is a quarter of a cookie. So you can see this is 1/4, and that it would take 4 pieces, and they're not going to look perfect, but that it would take 4 pieces of cookie to make one whole cookie. So that looks like it's about a whole cookie. So let's first start with seeing how many quarters do we have. So I have 1/4 cookie, 2/4 cookies, 3/4 cookies, 4/4 cookies, 5/4 cookies, 6/4 cookies, 7, 8, 9, and now I'm going to call them fourths, 9/4, 10/4, 11/4, 12/4. So what I have here is 12/4. And again, what I want to do is I want to turn these into whole cookies. So I'm going to go ahead, I'm going to write 12/4 over here. And I want to convert that into whole cookies. So let's model it here. Now we're not going to have a mixed number, we're going to actually just have a whole number. So let's take these and let's start doing it. So if I take again the first 4 fourths, it makes one whole cookie. And do you know why that is? It's because something I know is that 4 fourths is equal to 1 whole. So you can see that 4 fourths equals 1 whole cookie. So let's do this again. We've used up 4 pieces. So here's 5, 6, 7, and 8. But again, I could just really say that that's another 4 fourths. So now I've used up 4, 8. I've used up 8 fourths. Now I'm going to do the same thing here. And this is really what we've been doing just with math, is that we have been trying to compose these back together, all these fourths, into wholes. But we've been doing it by taking a fraction greater than 1 and turning it into whole numbers or mixed numbers. So here what you can see is that 12/4, so all these fourths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12/4 is actually just equal to 3 whole cookies. Is there another way that we could have done that? Could we have done that mathematically? Well, a really great way to do that mathematically is to just pull out of this 12/4 all these whole cookies. Remember, one cookie is 4 fourths. We can see that here. Remember, the denominator tells me the number of pieces that one whole cookie is made up into. 1, 2, 3, 4. And my numerator tells me how many pieces I have. I have 4 of them right here. So what I could have done is I could have taken my 12/4 and I could have pulled out groups of 4 fourths. So I could have said 4 fourths for this cookie, another 4 fourths for this cookie, and then another 4 fourths for this cookie. And now that's 12 fourths. 4 fourths, another 4 fourths is 8 fourths, and another 4 fourths is 12 fourths. So I've used up all my fourths to make these 3 cookies. And then what we can say is, well, this is equal to 1, this is equal to 1, and that's equal to 1. So this would be equivalent to 3 wholes. 1, 2, 3. So that's one way to do this. Let's try another one with the cookies. So let me pull them all off again. We're going to start over. And this time we're not going to have as many. So let me see what we're going to have this time. So this time, I'm just going to flip our page, and hopefully it'll be clean enough for us to work on. So here I have a bunch of fourths again. So let's see how many fourths we have this time. Oops, sorry. So we have 1/4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths. So again, we want to make whole cookies out of those 7 fourths. So I'm starting with 7 fourths, and I know that 4 fourths, oops, I went a little too high, sorry, let me bring that down. I know that 4 fourths is equal to one whole. And we modeled it with our cookies. So again, what I want to do is I want to pull out groups of 4/4 from that 7/4, from these 7/4. I want to make groups of 4/4. So let's see how many groups of 4/4 we can make this time. So here we have 1, 2, 3, 4. So 4/4 made up one cookie. So let me write that. Let's pull it over here. So I used up 4/4, and let's see what we have now after that. Oops. So I'm just going to slide this over a little so we have some room. And then here we have 1, 2, 3. We didn't even make up a whole cookie. We just had 3 more fourths. So we showed that we had 4/4 here. We wrote it there. And now we just have 3/4. And if you notice, 4 plus 3 is 7. What we're really saying is that we have 7 of these sized pieces. They're fourths. This is telling us how big our pieces are. It's telling us how many pieces make up a whole, how many pieces one whole is partitioned up into, right? So in this case, they're fourths, and we had 7 of them right here. We took 4 of them and put them together to make one whole, so we have 4/4, so that's just really one whole. And then we have 3/4 left. So what we have is one whole and 3/4. So I hope this is starting to make a little bit more sense. So now let's just kind of do another number, but let's not use the visual models. So let's go ahead and let's do another example. And we can just do it right over here on this table. I'll just turn it for us. So let's say that we were doing, let's do 11 thirds. So if we do 11 thirds, what I know is, let's imagine that I had that cookie. 3 tells me that I'm cutting it up into 3 pieces, right? That 3 in the denominator. And then what I know is that if I have all 3 pieces, that 3/3 is equal to one whole cookie. So imagine that I had a cookie that was cut up into 3 pieces and I ate all 3 pieces. I would have eaten a whole cookie. So 3/3 equals one whole. What I want to do is I want to take these 11 thirds and I want to start grouping them into groups of 3/3 to make whole cookies. So I have 11 thirds. I'm going to go ahead and I'm going to put 3/3 right here. So I've taken 3 of those 11 thirds. Let's put another 3/3 down. So now I have another whole cookie. So that's going to be 3, 6. I have to get up to 11. I can keep going. So let's do another 3/3. So now we have 3, 6, 9 thirds. If I do another 3/3, I would end up with 12 thirds, and that's too big. 3, 6, 9, 12. That's going to be way too big. And if you're good at counting by threes, you can just do that right now too. So instead, what I'm going to do is I'm going to have 2/3 because 3, 6, 9 plus 2 gets me to 11. So I have 3 pieces here. I had 11 pieces. I put 3, 3, 3. I'm going to put 2 of them here. And what size are they? They're thirds. So now what I see is that I have 1 piece, 1 cookie, 2 cookies, 3 cookies, or 1 whole, 2 whole, 3 wholes. Each one of these is equal to 1. And so that means that that's 3, but don't forget your 2/3. You have 3 and 2/3. So what I now know is that 11 thirds is equivalent or equal to 3 and 2/3. So we took a fraction greater than 1 and we converted it into a mixed number. It's mixed because it has both a whole number and a fraction, so it's mixed. Okay. Ooh, gesundheit. Okay, so now we want to be able to go the other way. So, I don't know, let's talk donuts. All right, so we are going to talk donuts. So I need a new page to work on for our donuts. So let me just pull up a couple pages here. All right, so we have some donuts. And my daughter helped me to cut this one out. She did a great job. It actually has a donut hole. However, and she cut one of these out too, but I was not quite so good. So I have a whole bunch of donuts here. But let's say that I want to stretch these donuts out. I don't want to eat them all in one day. And in fact, I want them to last a really, really long time. So what I'm going to do is I'm going to cut my donuts in half, and I'm just going to eat like a half each day. I want to know how many I end up with. So I think this is too many for us to work with. So let's just start maybe with 2 donuts. So if I have 2 donuts and I want to turn them into halves, let's see what happens. So first, let's go ahead and write 2, because that's what we're starting. Oops, that's what we're starting with. We're starting with 2 wholes. So we have 2 donuts, and we want to turn those donuts into halves. We want to figure out how many halves do we have here. So I'm going to go ahead and just show that we want to turn it into halves. So there'd be a 2 in the denominator, because that shows me that I'm cutting them each into 2 pieces or halves. So let's go ahead and do this. So I'm going to go ahead and take 1 donut and cut it in half. So there we go. And then I'm going to take the other donut and cut it in half. And that's all that we're doing when we're taking whole numbers or we're taking mixed numbers and we're turning them into fractions greater than 1. So now you can see that if I cut each of those donuts in half, I end up with 1, 2, 3, 4 halves. So I ended up with 4 halves. Now, for the most part, we are not dealing with taking a whole number and turning it into a fraction. We have not been doing that. That has not been our goal. So I don't want to focus on this particular one. What I want to focus on with you is what happens when we are taking a mixed number and turning it into a fraction greater than 1. So let's throw another half of a donut in there. So now what do we have? We have 2 whole donuts. So let's first put them back together and look at them the way they were. And then we had another half of a donut. So if I want to take, and I have 2.5 donuts, and I want to figure out, I want to turn that into a fraction greater than 1. It's going to be greater than 1 because it's more than 1 whole donut. What I'm doing is I am going to cut my donuts into halves. I'm going to turn everything into halves. And what you can see is that I have 1, 2, 3, 4, 5 halves. But how can I do that mathematically? What could I do to show that? Well, let's do it again, and let's try and show it mathematically. So I have 2.5. So we're going to start with our 2.5 again. Let me put them back together. And then let's do them one at a time. So I'm going to pull this 2, I'm going to have it be 2 1s, right? So I really could say that this is really like a 1 and a 1. Here's 1 whole donut, here's 1 whole donut, and then I still have my half of a donut. So what I can do now is I can pull each of those, I can turn each of those 1s into halves. And what I know is that 1 is equal to 2 halves, because remember, when our numerator and denominator match, it's equal to 1 whole. So now this becomes 2 halves, 1 half, 2 halves. So this really is 2 halves. What about this one? Well, again, the same thing. I'm going to have 2 halves. So I had 2 halves. Let me move this up. Sorry. I had 2 halves, and then I have another 2 halves. And then I still have this other 1 half. And then I can just combine them all. I can say, well, I have 2 halves plus another 2 halves is 4 halves, plus 1 more is 5 halves. So that's going to be 5 halves. And I can just kind of add them all up together. So what I did was that I kind of split them all up until I was able to figure out what I had. So I had 2 halves plus 2 halves plus 1. Let's do another one of these, but let's do it just strictly mathematically. And maybe we'll do a couple of these. So let's start with, let's say that I have 3 2/5. So again, think of our donuts. We have 3 whole donuts, but now we're going to be cutting them all up into fifths, 5 pieces for each donut. So think about that. I'd have my 1 donut, and I'm going to cut it up into 5 different pieces. Trying my best to make 5 pieces. They are, oh, I totally messed that one up. And I knew I was going to mess that one up. So let's do this. I'm better at doing it that way. So we have 1, 2, 3, 4, 5 pieces. So that's what we're doing. So we're going to take each of our donuts. So here's one donut. We're going to take this one donut and we're going to turn it into 5/5. And then we're going to take this one donut. So again, we have 3 donuts. So we're going to have 3 donuts. And I'm going to turn it into 5/5. And then I'm going to take this donut and I'm going to turn it into 5/5. But then I have to remember that I still have 2/5 hanging out there, right? Because I had 3 whole donuts and then I had 2/5 of another donut. So you might be saying to me, well, how do you know that you have to turn those into fifths? Because I have a 5 in my denominator right here. And whatever's in your denominator is what you are going to be decomposing your whole number into, so that you can combine them. Because remember, we need common denominators to add. So what do I have here? I have 5/5 plus 5/5 plus 5/5 plus 2/5, which is going to be 5, 10, 15, 16, 17 fifths. Now, I don't know if you just noticed what I did, but I was just counting by 5s, which is another thing you can do, and we'll get to that in a second. But I want to show you another way of writing this. How many times did I add 5/5? I added 5/5 3 times. And then I still had to add on that other 2/5. So I had 3 donuts. I turned them all into 5/5. I have all 5 pieces. I cut it up into 5 pieces. I have all 5. So I took 3 donuts. I turned them all into 5/5. And I had 2/5 of a donut more. Again, how many times did I add 5/5, or how many times did I cut donuts into 5/5? 3 times. And that's just going to be 17/5. So that's another way to look at it. Now, today in our Google Classroom, you guys figured out something really cool. And we were looking at this. And another way that we figured out we could do this was, remember what we did? We have 3 and 2/5, and we figured out that algorithm shortcut, where what we figured out was that I can really just do 3 times 5 and add on the 2. So we did 3 times the denominator, whole number times the denominator, and add on the numerator. But you have to remember to hold on to your denominator. So remember the shortcut, 3 times 5 is 15, plus 2 is 17, and we keep our fifths. Okay, but if you don't see this, keep working it that way. Let's do one more. So how about we do, let me flip this, that'll be an easier way to do this. Let's do, I don't know, let's do 4 and 1/3. So what's going on here? We want to take these 4 wholes and turn them into thirds. So I could think of it like this. I have 4 wholes, and I know I'm pulling them all apart instead of putting them in one tape diagram. So I have 4 wholes, and I want to turn them into thirds. I also have a third right here, so that's a third. And these are all equal to 1 whole, and I want to cut them into thirds. So each time I'm cutting them into thirds, I could model it over here. So I had this whole, and I have 4 of them. So 1, 2, 3, 4. And I'm cutting them all up into thirds, 3 thirds. So I'm going to have 3 thirds here, and I'm going to have 3, and I'm decomposing them. 3 thirds for this one. Do the same thing here. Another 3 thirds. And I'm doing the same thing here. I have another 3 thirds. So all those wholes, 1, 2, 3, 4, were decomposed into thirds. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right here I have 12 thirds. But don't forget, you still have 1/3 left. So we want to put those together. So I'm going to have a total of 12 thirds plus 1/3 is 13 thirds. And here's where that other third was. So we had 4 wholes and we had an extra third. Okay, so again, another way of saying this would be that I had 3 thirds 4 times. So I could say 4 times 3 thirds. Or I have 4 wholes and I'm cutting them up into 3 thirds each. And then I have to remember that I still had that 1/3 left over. And that was 13 thirds. I think this is probably going to be the easiest way for you to do it, is to pull out 3 thirds. It's really similar to when we're working with the fractions greater than 1 and we're pulling out the wholes. But here we're taking the wholes out of here, out of the whole number. We're pulling out all the wholes and we're turning them into thirds. Okay, so I think that probably makes a lot of sense, I'm hoping. This was another review. I hope the manipulatives helped you, the donuts and the cookies. So just remember donuts and cookies. And I will see you in our Google Classroom. Have a great night.